Hey class, and welcome to the next video in the equations unit, and this is fractional equations. So these can look like some of the most awful equations you can think of, but they're really not bad at all. And I'd say if I sound a little different, I'm a little under the weather, got a little throat thing going on, so just excuse that. And let's get to our first example so you can see what a fractional equation looks like. So here's an example of one. I just hammered it because it's kind of annoying to make fractions typed well. So you have a over 10 plus 3a over 5 equals 7. And what's different about this obviously is that there are fractions, there's denominators, and the first thing that we're going to do is get rid of the denominators. And we do that by finding something called the LCD. And LCD does not stand for liquid crystal display, which is the screen that I'm looking at right now. It stands for least common denominator. If you've heard also of LCM, it's the same thing, least common multiple, but the D is more specific to this type of problem where there's denominators. So the LCD, we actually would say LCD of, and then all the denominators are 10, 5, and 2. So we're looking for a number that 10, 5, and 2 can all go into. And what we do is you take the highest one, and you first check that one. So does 5 go into 10? Yep. Does 2 go into 10? Yep. So 10 it is. If one of those didn't go into 10, I'd try the next multiple of 10, which would be 20, and see if they all work for that. 20 does work, but it's not the least common denominator. So I want the smallest one all three numbers can go into, and that would be 10. So I take that 10, and I multiply every single term by 10. Even if one of the terms isn't even a fraction, it has to be every term. And remember, terms are separated by the plus sign and the equal sign. Okay, now, and this next step is a little weirder. Right now I have 10 times a over 10. But before I do any multiply, which is what this is, I'm going to cancel what I can. So right here I have a 10 on top and a 10 on the bottom, and they just go away. And what's left is an A. Right? The signs stay the same right here. And on this one I have a 10 on top and a 5 on the bottom. They don't just both go away because 10 divided by 5, 10 divided by 5, there you go, is 2. So you don't normally have to write this at all. I just wanted to see what I was doing. And you leave what's left there. So whatever's not crossed off is still there. So it has still have a 2 and a 3a in this term, and they get multiplied together. So you want to multiply these right here. And that would be 6a equals, and then this thing here, we're going to cross the 10 and the 2 off. And 10 divided by 2 is 5. Alright, and we're going to multiply these two right here. So 5 times 7 is 35. Alright, so we have this new equation that looks much simpler and is usually like a two-stepper. In this case it is a two-stepper. A and 6a, or 1a and 6a, can be combined into 7a. And then there's one last step to divide by 7. And a equals 5. To do check for a fractional equation can be a little bit of a pain in the butt. This one's not too bad. I want to show you this one. So we're going to rewrite a over 10. I'm going to write check first. Check a 5. So a over 10 plus 3a over 5. So 2. And I'm going to replace, I get 5 over 10 plus 3 times 5 over 5 equals 7 over 2. This is 1/2 here, this 5/10, plus 15 over 5 equals 7 over 2. And then, so 15 over 5 reduces just to 3, but You see 3 is not really the form we wanted in. If we want this side to be 7 over 2, we got to get this to be the same as over 2. So off to the side, 3 is the same as what over 2? Well, I got to multiply this is 3 over 1. So that means I multiply this by 2. So I got to multiply this by 2. And you get 6 over 2. So this is 1/2 plus 6 halves equals 7 halves. And that comes out nicely. Sorry to squish it in here. So 7 halves equals 7 halves. And it works. So I'm going to make this disappear, so pause it if you have to get it down. I'm going to bring up another example. Change my color too. Alright, so in this example, I'm on the wrong here. Hello. Yes, I know. Okay, so in this example, we do have a term that is not a fraction, so you can see what that's like. So we're still thinking LCD, and the LCD of 3 and 6 would be 6. That's the easy one. 3 and 6 can both go into 6. That would be the smallest number that they both go into. So I'm going to multiply everything by 6, and that includes 12. It has to be every term. So when you do 6 times 12, that's all it is, 6 times 12. There's nothing to cancel it with. So that would be 72 minus. So now we can do some canceling here though. 6 and 3 cancel. 6 divided by 3 is 2. So now I have this 2 and this 4 that get multiplied together. And you get an 8x equal. And then what's nice is this 6 and this is gone. And that's an x. Okay, so now it's just a two-stepper again. I want to get these x terms together. They're not on the same side, so that's combining. I have to do the opposite operation. So I'm going to add 8x to both sides. This one's a 1, so when they get together it's a 9x equals, this whole thing is gone, 72. So you can see, after you get rid of the denominator, it becomes pretty easy. And then x equals, that's a nice 8. I'm going to do the check a slightly different way this time, just to show you the other ways you can do it. So let's say check x equals 8. Right now, and we're going to replace, so none of this is different. 4 times 8 over 3 equals 8 over 6. You can see how these are not going to come out like super nice. 4 times 8 is 32 over 3 equals 8 over 6. This is pretty. So at this point, grab a calculator and get decimals. And instead of having a fraction on both sides that are the same, we're hoping to get a decimal on both sides that's the same. Right, so it's 12 minus, and then 32 over 3 is the same as 10.6 repeat. And then 8 over 6 is the same as 1.3 repeat. So we just got to subtract these. 12 minus 10.6 repeat is, in fact, 1.3 repeat. I was just confirming with my phone calculator to make sure it would work. So if you don't like fractions and you have yourself a calculator, you can definitely just get them down to their decimal version, and you can work with them a lot easier. You don't have to know any fraction tricks for the check if you don't want. Alright, the next one and the last one that we're going to do together looks like this. Pick a new color here. Brown. Alright, now we have an LCD again. Or we want to find the LCD, excuse me. And that would be of 8, 12, 24. Again, I picked my biggest one. I look at my biggest one and I say, do these numbers go into 24? Yes, they do. So we're going to use 24. If it didn't, then I'd have to try 48 next and hope that I get to it soon. So 24, that's what I'm multiplying everything by. I love these because they just go away, they're just gone. So I know this is equal to 51 still. Over here, 24 divided by 8 is 3, and 3 times 5 is 15. Keep the k. Over here, 24 divided by 12 is 2. 2 times k is just 2k. So you can have one that, you see, this just didn't look pretty, did it? And in the end, it's really not bad at all. These come together, this is 17k equals 51, and I'm pretty darn sure this is 3. I'm just going to make sure. 51 divided by 17, yep. So you get k equals 3. And I'm going to skip the check this time. I showed you both ways to do the check. You can try yourself, figure out which way works best for you. And I have one more to show you that we're not going to do together, and you can probably guess it. You're going to do it on your own. I'm going to make that one disappear. This is the one I want you to do on your own. So remember a couple things here. You want to write what your LCD is. You want to multiply everything by your LCD, including this 10. You want to do some canceling. And I want you to attempt the check. I don't think this one's too bad. You can use the decimal way or you can use the fraction way. But I do want you to attempt the check. So this is what I'll be checking in your notes that you have done. Is number 4. Good luck, and I'll see you in class.